So again, section 8.8 part B, improper integrals. This popped up in your classroom yesterday, your Google Classroom, and then I took it out because I'm like, oh, wait a minute. There's people testing. I think I only had 5 people in my class. I'm like, yeah, I'm not going to teach and then expect you guys to do your SATs and then watch a video of me doing stuff. So I figured I just wouldn't do it. So today, I think, let me check. Did it update? Yes, it did. So I'm just looking right now. Your instructions are there. You have page 587, 37, and 39, 59, and 61 as homework. Okay, so that is in your Google Stream right now. So let's continue with what we were doing yesterday, or not yesterday, but the day before yesterday. But this time, instead of using infinities, we're going to do stuff like this. Okay, so this looks very normal, right? Most people would just kind of say, all right, well, what I'm going to do is I'm just going to rewrite this from 0 to 1 of x to the negative 1/3 dx, and then I'm going to integrate. And most people aren't even going to give this a second thought. But here's the problem, though, guys. Whenever you do integration, you have to ask yourself, this function, 1 over x to the 1/3, does it exist between 0 to 1? Like, is there a nice continuous function that exists between 0 to 1? If I were to plug in my 0, would it work? If I were to plug in a 1 right now, like if I were to actually plug in a 0 and plug in a 1 into it, would it work? Right? And if you look, if you plug in a 0, this thing kind of breaks apart, right? Because you're dividing by 0. Okay? So that's, kind of like a bad thing for us. Now, let's check this out here. We're going to graph 1 divided by x to the 1/3. Okay, and let's graph this. We said we're going to take the integral from 0 to 1. So let me zoom in again here. I'm just going to zoom in. Now, if you try to do the integral from 0 to 1, what you're going to notice, right now you can see that picture, so if I can just kind of draw it for you. So you have a picture that kind of looks like this from 0 to 1. Now, let's just pretend this is our 1 right here, okay? The area they're talking about is all of this. But the problem is that going towards the left is never going to end because the graph is just going to get infinitely close to the y-axis, but it's never going to touch the y-axis. So it's never going to actually seal. It's never going to cross the y-axis to make a seal. Like, we can seal it at 1 because we can just put kind of like a line right there. But you'll notice that the green part going to the left is never going to actually close up. So that means that the area is infinite, right? So that's a problem. This is an improper integral because from 1 to the left, it's good, but from 0 to the right, it's not good. There's a gap here, okay? There's a little gap that occurs even up until infinity. There's always going to be a small gap because that line cannot touch the y-axis. So this is called an improper integral. You have to ask yourself, between my interval from 0 to 1, does anything cause a problem? Now for us, 0 will cause a problem. So what we're going to do is we're going to rewrite it. We're going to do the limit as, and in our case, remember, it's from a to b, right? So since 0 is my problem, I'm going to say from a approaching 0 from the right side, okay? So whenever we use numbers, we have to think, okay, 0 to 1, here's 0. Look at the graph to 1. You can only approach 0 from the right, and you can only approach 1 from the left. Okay? So make sure you remember that. Okay, when you're approaching the left-hand side, you have to come in from the right. Okay? when you're approaching the right-hand side, you have to come in from the left. All right, so we start with that, and then we're going to put integral from a to 1 of x to the negative 1/3 dx. Now we are going to just integrate like normal, so limit as a approaches 0 from the right of the integral of x to the negative 1/3 becomes x to the 2/3 divided by 2/3. So it's x to the 2/3 times 3/2. Okay. So that's what it becomes. It's x to the 2/3 divided by 2/3, but if you divide by 2/3, just multiply by its reciprocal, so 3/2. Okay. And if you want to, you can do the following. I usually do. Limit as a approaches 0 from the right of 3/2. I take out the fraction because why do I need to worry about the fraction when I'm plugging in numbers? So limit as a approaches 0, 3/2. Now I plug in a 1, so that's 1 minus, that's a to the 2/3. Okay, now you're going to plug in your 0. Okay, you're going to plug in your limit as you go from the right side, okay, for a to the 2/3. Now let's see what a to the 2/3 looks like. You can use direct substitution, but let me just get a to the 2/3 as a graph, okay? So in other words, x to the 2/3. Okay, so there's my graph. Now, remember what it said, all right? Let me see if I can do this. I'm not sure if I can. Can I do this side to side? Yes, I can. Okay, awesome. So, look at my graph of a to the 2/3. When I plug in a 0 from the right, what is the value? I'll even zoom in here for you. Let's zoom in. What is the value as a approaches 0 from the right? It actually has the point there for you. Anybody tell me? Actually, I don't need this anymore. So 3/2, 1 minus 0. Okay, do you guys understand that? Why it's a 0? Remember, the graph looks like this. Just kind of drawing the graph really quickly here. So as you approach 0 from the right, it's right there at 0, 0. That's why the value is 0. So then the answer to this question is just 3/2. So notice you are going to have to go back a little bit and remember limits and how to apply them. Okay? You can't just plug numbers in, because sometimes that 0 from the right side might be infinite. You don't know. You have to look at the graph. It is not the correct syntax. So yeah, they could mark you wrong. Now you only need to do this whenever you're doing improper integrals. So, and you should now, knowing this, you should always check to see if the integral is proper. It doesn't happen very often, but you know, it can occur. So let me give you another example here. So this was example number 2. So let's do this integral from 0 to 2 of 1 over x cubed dx. So kind of the same idea. Okay, and then we'll do one that actually has a dual. So one that'll be a little bit different. We're going to use the same problem, but as example 2, but we're going to kind of change it around a little bit. So again, you look at this integral, it looks very normal, but then you look at its graph, right? So if you look at its graph, it's going to be 1 over x cubed. And you're going to look at the range from 0 to 2, okay? And I don't know why I didn't graph it. What's going on here? 0 to 2. Oh, it's because I was zoomed in. Sorry. Let me fix that. Negative 10 to 10. All right, so notice from 0 to 2, it shows it for you right there. Okay, you can see how the area, okay, that's given to us right here, to the left side, I think if I do this, hold on, so I can draw on the picture. It's going to take a screenshot for me and then open it up, so hold on. I hope that's what it's doing. Is it asking me to pick one? Oh, okay, nice. Okay, I've never done that before. So check this out. The area right here is all okay, but once we go up, okay, this area just keeps going up and up and up and up and up forever and ever and ever, right? So that's a problem at 0 because the area is never going to stop getting bigger. It's going to keep getting bigger forever and ever and ever. So what I need to do then, don't save that. So what I need to do is I need to say, okay, 0 is going to cause a problem. Okay, so since 0 is going to cause a problem, I need to substitute it out. So we're going to do what we just did. The 2 doesn't cause a problem. Remember, you could always just plug them in on the edges and see if it works. And if it does work, then great. Then you can maybe just do your normal integral. Sometimes it won't work in between, and that's our next example. But usually you can just plug in the edges and then you graph the picture to see if anything occurs in between. Okay, so but 0 wouldn't work. You could see if you plug in a 0, it's going to cause 1 over 0. 2 would be just fine. That'd give us a 1/8, so it's not a big deal. But for this one, we're going to rewrite it. Okay, and then we're going to integrate. Again, the integrals are not the hard part. Okay, doing the integrals is going to be very normal. So this will be x to the negative 2 over negative 2, or if you want to write it as negative half x to the negative 2 from a to 2. And I just do that just so I can get the fraction out. So negative 1/2 x to the negative 2 from a to 2. I probably should have written this as a 1 over x squared. I think that would make more sense. Okay, so I have the limit as a goes to 0 from the right of negative half of 1 over 4 minus 1 over a squared. And I want to find out, what does 1 over a squared look like as I approach 0 from the right? Do I have a value for it? So again, I'm going to have to graph it. Okay, so I'm just going to use this right here. What's that? Put a 2 there and graph it. Okay, so let me do a standard window, or a standard zoom, I mean. 6, 5. All right. So if I zoom in just to kind of see it a little bit better, what's my answer? What is my limit as a approaches 0 from the right for 1 over a squared? For this right here, where is it going to? 0 from the right. Anybody know? Carly just left. She didn't know. She just took off. No, I'm guessing she disconnected. Nobody? Remember, it's going, here's the curve, right? Like that. So as it approaches 0 from the right side, it's going that way. Where is it going to? Positive infinity, right? So this is going to plus infinity. So my answer here is a negative half, a 1/4 minus infinity. Well, 1/4 minus infinity is negative infinity. And negative half times a negative infinity is positive infinity. That's my answer. It's infinite. Okay, this diverges. It has no actual area that can be found within that interval that they're giving you. Okay, it's infinite. And that's okay. There's nothing wrong with that type of answer. The one up on top, we had a convergent answer, right? We could say this converges. If they ask you whether it converges or diverges, that one converges. This one diverges. Okay, so remember, you have to look at your graphs. Okay, look at your graphs and see what happens. That way you can tell, like, okay, according to what I have here, this is where it's going. So I want to do the same problem, guys, but in doing the same problem, I'm going to change my limits. So example number 3, we're going to do the integral from 1 to 2 of, we'll do 1 over x cubed again, okay? Same problem. Remember, the purpose of this lesson is just to show you what to do when the limits kind of mess up. Remember, for the ones with the b, just in case you, well, we're not going to be able to do one just because of time constraints, but if the b value is the wrong thing, in other words, if the top part is the problem, then you're going to do limit as b goes to the number, but from the left. Okay, you're going to put a minus sign. Okay, the a's you put a plus, the b's you put a minus. All right, now let's check out this last problem right here. So what you do is you're going to want to plug in the numbers, right? You plug in a 2, you get 1/8. You plug in a -1, you get a -1. You're like, oh, okay, that's great. Right? Everything works out perfect, no problem. Right? So then people start doing the work. But here's the issue. Between -1 to 2, there is a problem with this graph, because between -1 to 2, 0 does exist. Right? 0 is in between this interval from -1 to 2. So since 0 is going to cause a problem for us, we have to split it up so that we can fix it. So this is how we split it up. So notice I'm still doing the whole interval from -1 to 2, but what I'm doing is I'm emphasizing the point of disaster, I guess you could call it, right? This is where the thing's going to mess up. And I do that on purpose so that I can use my limits to help me do the work. So the first integral, I'm going to write limit as b approaches 0 from the left. Okay, and that's integral from -1 to b of x to the -3 dx. And then for the second one, I'm going to write the limit as a approaches 0 from the right. From a to 2 of x to the -3 dx. Okay, so there's the use of a and b. Okay, so let's do our integration and stuff like that. So I'm going to it's going to look a little weird because I'm trying to save a little bit of space for my calculator to actually be seen. So I'm going to move it back a bit. So this is the limit as b approaches 0 from the left. From the left. And then this integral is negative 1/2 x to the negative 2. Or you know what? Let me rewrite it nicer. Negative 1/2 1 over x squared, negative 1 to b. And then minus, and the reason why I put minus is because it's going to be the same integral for the other one. So instead of writing a negative 1/2, I'm just going to put minus. Limit as a goes to 0 from the right of 1/2 of 1 over x squared from a to 2. So now I'm going to go ahead and put in my values into my integral. Okay, so this is limit as b goes to 0 from the left of negative 1/2 of 1 over b squared minus 1, right, because you plug in your negative 1, minus limit as a goes to 0 from the right of 1/2 of 1/4 minus 1 over a squared. Okay, are you guys okay so far? I'm just kind of doing the integrals. I'm just having to do two limits at once. So I'm going to take the limit as 0 as it approaches 0 from the left hand side. Okay, so it approaches 0 from the left hand side. So 0 from the left hand side for us is going to be negative 1/2 1 over b squared. Remember, 1 over b squared, I think I already had it here. There's the on button. So there's 1 over b squared. 0 from the left hand side, so that's from the left of that graph. Going up, that's a positive infinity, right? Minus 1 minus 1/2 of 1/4. Okay, minus, now 1 over a squared, as we approach a from the right, that would be an infinity. Okay, so in this case we got a positive infinity. Actually, no, I'm sorry, a negative infinity. And then over here on this side, we're going to have a positive infinity. Okay, so this is what's called a indeterminate form. Now here's the good news. Okay, I do this problem mostly to show you the process, not because of the answer. Okay, because what's supposed to occur at this point is you're supposed to say, wait a minute, that's one of L'Hopital's rules, and I'm supposed to do specific work for it. Okay, but remember what I told you guys about the indeterminate forms. There's only two that you need to worry about. There's the infinity over infinity and the 0 over 0. Okay, those are the only two you have to know. You will not get a problem whose answer comes out like this on your homework. Okay, my purpose was to show you this. Okay, how you get an original problem that has a value in the middle there's the bell, that has a value in the middle that doesn't work, and you have to split it up yourself. Okay? Any of the problems that I give you should work out nicely. Okay? So they shouldn't come out to one of these indeterminate forms. If anything, it's going to give you either just infinity, or it's going to give you like a fraction or a whole number or something like that. Okay, so we're going to basically stop at this point because we don't need to. In BC, you don't have to know how to do negative infinity plus infinity or infinity minus infinity. You're not responsible for that. But again, my whole point was not the solution. My whole point was to get you to go through the process of splitting it up and what it would look like when you start doing the work to the very end. Okay, so your homework is given to you guys. I'm guessing tomorrow I'm just going to give you a book day so we can talk about this if you need to. Remember, did I tell you guys are taking a test on Monday? Isn't that what we voted on? Okay, so yeah, Monday. So tomorrow, use your time with me to ask questions and things like that, okay? I'll let you know tomorrow if it's going to be a test or just a quiz, okay? Maybe we don't do a test and we just cover the last 3 sections or so that we did. So sorry for kind of going over here. If you want to stay and ask questions, feel free. If not, have a good rest of the day.